Welcome back to the deep dive. Today we're focusing on something just colossal and completely relentless happening right over your head. And chances are, unless you work in, say, logistics or air traffic control, you have absolutely no idea it's even there.
It really is the ultimate invisible phenomenon of modern life, isn't it? If you step outside, you look up, and what do you see? A huge, open, mostly empty canvas.
Right, maybe a single plane, a few contrails. We're just conditioned to see the sky as, quiet.
Exactly. But the reality, according to the sources you shared with me, it suggests the complete opposite.
It really does. Our source material, which is drawn from an analysis of global aviation logistics, it just shatters that assumption of emptiness right away. The main source we're looking at used this great phrase, "Shis a la corona," the hidden traffic jam in the sky.
And that framing is perfect. It sets the stage so well. Because our mission today, it isn't just to say, oh, the sky is busy. It's to uncover the truly shocking, almost unbelievable scale of the planet's global air traffic flow. And, the key thing is to peek behind the curtain at the systems that actually run this hidden world.
Okay, so let's jump right in. Let's get to that astonishing number that really kicked off this whole deep dive for us. The question in the source material was simple. What's moving above our heads that we don't notice? The answer they gave was, well, it was mind-bending.
And this is where we have to apply a little bit of our deep dive skepticism.
Yeah.
Especially with big numbers that are designed to shock. The source stated, quem 40 cent kingdom gotcha. Yeah. 40 cent king Jake. Yeah, eat same seat king.
40,000 planes crossing the globe every single second.
Right. And as you and I talked about, that figure, 40,000 movements per second. It's just not possible.
Yeah.
Mathematically, scientifically, it's impossible. The sky would be solid metal. But what we need to do as analysts is figure out what they meant by that.
Because the reaction in that original conversation was just screaming, A-U-Z-A, A-U-Y, A-C, A-A, A-Z, on-low. A crazy number. And they used it to define this idea of a global air traffic flow, or the constant A-A-O-Z, aqui what's the A-Austery.
It's designed to convey a sense of scale and speed, but of data, not of literal planes. A more conservative, globally accepted number is probably closer to, say, 18 to 20,000 commercial and cargo planes in the air at the same time, during peak hours.
Okay, so flights per day would be?
Per day, you're looking at well over 100,000 movements, globally, comfortably.
Okay, so let's ground ourselves in that corrected number, which is still staggering. Up to 20,000 planes in the air at any given moment, 100,000 flights a day. That's the global air traffic flow we're talking about. And when you think about the weight of that, the metal, the people, the cargo, it changes how you see the atmosphere entirely.
It does. We talk about a traffic jam on a highway that's two-dimensional, it's physical, you can see it, it's slow. This is a three-dimensional traffic jam. It's invisible.
Right.
And it's moving in multiple directions at different altitudes, all at incredible speed. That scale immediately makes you ask about the management.
Right. If we accept this ceaseless volume, the question isn't how many, it's how. How on earth do you manage a 247 global operation with tens of thousands of vehicles moving at 500 miles per hour across, dozens of different airspaces?
And that's the core of it. What's so fascinating is that this is a network that, as the source says, it doesn't stop for a moment. It's unceasing. And because it's unceasing, it demands absolute real-time coordination. The system has to predict where the congestion will be hours before it happens.
So in our source, the management system was kind of glossed over. It just said it relies on Kotlookabat satellites and radars. But for our listeners, that's too simple. Can you unpack the actual tech layers behind this hidden traffic jam?
Certainly. We're talking about a huge paradigm shift in how planes are tracked. Historically, it was just primary radar. The ground sends out a ping, waits for the echo, but that only really works over land.
And within a certain range.
Exactly. Today, the system is moving more and more to something called ADS-B. It's Automatic Dependent Surveillance Broadcast.
Right. That's the system where the plane itself is constantly broadcasting its own super precise GPS location, its speed, its altitude, all of it.
Precisely. It's dependent on the plane's own systems, but it's automatic, and it's broadcast to the world. And this is critical for the flow because it turns every single plane into a constant live data point. This data gets picked up by ground stations, sure, but the real key is it's also picked up by low Earth orbit satellites.
So the satellites are talking directly to the planes. It's not just ground control talking to satellites. That's how you solve the problem of tracking planes over the middle of the ocean.
You've got it. If you look at something like the North Atlantic tracks, thousands of flights between North America and Europe every day. For decades, they relied on procedural control, basically giving planes huge safety buffers because they couldn't actually see them in real time. Now, with satellite-based ADS-B, they can tighten those separations because they have continuous high-fidelity data.
So the system is always tracking these thousands of planes all at once, ETU istici, over countries, cities, and these vast oceans. The coordination, though, to hand off a flight smoothly from, say, Canadian airspace across the Atlantic into Irish airspace, that must be a logistical nightmare.
It's a phenomenal achievement, and it relies heavily on the flight management system, the FMS, inside the cockpit. The modern system isn't really about controllers manually guiding every plane. It's about the ground systems feeding predictive data to the FMS on board, and the FMS flies the most efficient, pre-cleared route. That's the only way you can scale up.
Okay, that level of integration, it sounds almost perfect, but we all know it's not. We still see massive delays, congestion at hubs like Chicago or Frankfurt. If the network is so integrated, why do the bottlenecks still happen?
That is a fantastic question, and it really challenges that idea of a perfect network. The complexity we're talking about, that manages the sky. But the bottleneck, it's almost always on the ground. Air traffic flow is three-dimensional, but it has to collapse back into a two-dimensional bottleneck.
Yeah.
The airport runway.
Right, the physical limits, takeoff and landing slots.
Exactly. You can optimize the flight from New York to London perfectly, but if London Heathrow only has capacity for, say, 45 landings an hour, every plane, no matter how efficient its flight was, has to get in line. That's why the big projects like Caesar in Europe and NextGen in the US, they're focused on predicting and allocating those bottleneck slots months in advance.
Which brings us to the psychological part of the source material, this total disconnect between this massive constant flow and our awareness of it on the ground.
It is a fascinating contrast, isn't it? The source noted that the most amazing thing is that, it's a shayeri. Yeah, you show. Most people live their lives and just don't know this is happening. You could be walking your dogs, focused on this tiny task, totally oblivious to the fact you're under a massive, constantly shifting ceiling of global transit.
It gives you this feeling of living under an unseen, moving lid, buzzing with activity, and that's where the source used that really powerful analogy to describe it. They said the planet moves
As if it were a giant beehive. I love that image. It just instantly conveys organized chaos. From the outside, a beehive is just a structure. It looks calm, still. You see a few bees going in and out. But inside, it's a frantic, interconnected world of ceaseless work, transit, communication, all for one goal.
And the air traffic flow is exactly that. Constant work, constant transit, all for the singular, organized economic goal. Even if the crews on each plane almost never see the other 19,999 planes around them.
It just emphasizes that stillness is an illusion in almost every major system. We think the ground is stable, but we know about plate tectonics. We think the sky is empty, but now we know it's a high-speed, three-dimensional grid. The host in the source material captured it perfectly. He concluded that Siror eshisufue, eshisofue. The Earth never calms down, not above, not below.
It really reframes our place in the world. We're living inside this operational system of just phenomenal complexity.
And that, I think, leads us to the key takeaways. The first one is just that the reality of global movement far, far surpasses our conscious awareness of it. When you think globalization, you need to picture those 20,000 planes in the air right now. That's the true face of global infrastructure in continuous high-stakes motion.
And the second takeaway has to be about the systems themselves, that absolute reliance on integration.
Absolutely. The importance of systems thinking is everything here. That volume, the 100,000 flights a day, it only works because of integrated, predictive, adaptive technologies. If one single piece fails, a radar station, a satellite link, the coordination between two countries, the entire system, the whole beehive, is at immediate risk of chaos. It's a testament to technological harmony that it works so well.
This has been absolutely fascinating. We started with such a simple question. What is moving above your head that you never notice?
And we found the answer. A hidden traffic jam of such a staggering scale, tens of thousands of aircraft movements happening constantly, that it turns the entire planet into this giant, buzzing, invisible beehive of transit, all managed by these incredibly sophisticated satellite-driven systems like ADS-B.
Well, thank you for sharing these sources and for letting us dive deep into this hidden layer of our world. It's truly amazing what operates completely unseen.
Our pleasure. But let me leave you and our listener with one final thought. It's based on that beehive idea. We talked about the complexity of keeping 20,000 movements from colliding. Now think about the sheer volume of data, the precision, the predictive power needed globally every millisecond just to keep that beehive from collapsing. If you actually try to calculate the amount of data needed to track, sequence, and predict the movements of 20,000 objects in 3D space, all moving at high speed, it makes you realize something. The most massive hidden infrastructure above us might not be the planes themselves. It might be the oceans of processing power required just to keep them apart. Something to think about next time you look up.